This video is on the axis of symmetry of a quadratic. The graph of a quadratic function is symmetrical about a vertical line. This line is called the axis of symmetry. So you can see in that diagram there, right down the middle of the parabola, so it goes to the maximum or the minimum point, is where the axis of symmetry lies, directly in the middle. If the graph has two x-intercepts, then the axis of symmetry is midway between them. That's a really important thing to remember because sometimes you may only be given x-intercepts and you need to be able to find the axis of symmetry on that. So remembering that it's in the middle is going to be a really good thing to do. We do have an equation for the axis of symmetry of a quadratic function. The quadratic needs to be in the form y equals ax squared plus bx plus c. And if we have it in that form, the axis of symmetry equation is x equals negative b over 2a. So it finds that x coordinate where the axis of symmetry lies. Another quick thing to note is the axis of symmetry is a vertical line, which means its equation will always be x equals and whatever x value it corresponds to. Example here, find the equation of the axis of symmetry of the following. Part A, we have this graph and we have two x-intercepts at 2 and 6. The axis of symmetry is going to be right down the middle there. So to find where that is, we just have to find the middle of 2 and 6. And hopefully we'd all be able to see that that would be 4. So the equation of the axis of symmetry would then be when x equals 4. You will find with these questions, it will always ask for an equation, which means you can't just write an answer of 4, you have to write x equals 4. If you don't write the x equals, you will lose marks in an exam. Part B, we have y equals 2x squared plus 3x plus 1. Now in this situation, we've got an equation, which means we can use the formula that's at the top of the screen there, of the x equals negative b over 2a. The a and the b are just exactly the same as they are when we look at the quadratic formula. So the a is 2 and the b is 3, and we just sub them into the equation of x equals negative 3 over 2 times 2, which equals negative 3 over 4, and that is where the axis of symmetry lies. And as its equation, we always have to write x equals in our answer. And that is the axis of symmetry. Vertex of a quadratic. The vertex, which can also be called the turning point of the quadratic function, is a point at which the function has a maximum or a minimum. It's that turning point where it changes direction. Since the vertex lies on the axis of symmetry, as there is right in the middle of the quadratic, its x-coordinate can be found using our axis of symmetry formula, the negative b over 2a, if you have that information there to be able to put that into the equation. First example here, for the functions y equals negative x squared plus 2x plus 3 and y equals 2, bracket x minus 2, and then the next bracket x plus 4, we want to find the axis intercepts, the equation of the axis of symmetry, coordinates of the vertex, and then we are going to sketch the function. First of all, let's start with the y equals negative x squared plus 2x plus 3. So part A, find the axis intercepts. The y-intercept is really easy because we have it in this form, which means the y-intercept is the plus 3 that's added to the end. So it is at 0, 3. Our x-intercepts, we are going to need to find ourselves. Once again, see if you can factorize, quadratic formula. If you have a calculator in the exam, use your calculator. Whichever method works for you. I'm not going to do a method with this one, I'm just going to give the answer. In previous videos, there is information how to solve a quadratic by all the different methods. So when we do solve this and find our x-intercepts, we'll find they are at when x equals 3 and when x equals negative 1. So our coordinates will be 3, 0 and negative 1, 0. Part B, we want to find the equation of the axis of symmetry. Different ways we can do this. We can do it using the formula because we have it in the form of ax squared plus bx plus c, or we also have the two x-intercepts, so we can find the middle of the two. Completely up to you which way around you would like to do it. Both are valid methods, so completely up to you. If we do the negative b over 2a method, the equation will have negative, the b is the value in front of the single x, which is 2, over 2 times the value in front of the squared x, which would be negative 1, and this will give us an answer of 1. So our axis of symmetry equation is when x equals 1. The coordinate of the vertex, so the vertex, remember, is at the maximum or minimum, but the x value of the vertex coordinate is the axis of symmetry. So in this situation, we know the vertex occurs when x equals 1. We now just need to find the y coordinates of that, so we can just put the 1 into our original equation. We'd have y equals negative 1 squared plus 2 times 1 plus 3, and you will find we get an answer there of 4. So therefore the coordinates of the vertex will be at 1, 4. And then part D, we want to sketch the function. And we have all the information we need now to be able to sketch it. So just draw up some axes. We have our y-intercept at 0, 3. Our x-intercepts at 3, 0. And negative 1, 0. And our vertex is going to be at 1, 4. And once we've got some dots there, you see I've got more information, so I can draw a more accurate sketch of the function. Right, let's look at the second equation we're given in the question, which is y equals 2, and then x minus 2 in brackets, and x plus 4. And we're going to do the same thing here. So part A, we want to find the axis intercepts. To find the y-intercept, we just need to make x equals 0. So we'll have 2 multiplied by 0 minus 2 multiplied by 0 plus 4, which will give a y-intercept of negative 16. Because we already have it in brackets, it makes it really easy for our x-intercepts. We can then know that they will just be when x equals 2 and x equals negative 4. So our coordinates there would be at 2, 0 and negative 4, 0. Part B, find the equation of the axis of symmetry. Now we don't have it in the form of ax squared plus bx plus c, so the easiest way would be to find the middle of the two x-intercepts of 2 and negative 4. If you can't see where halfway would be, a really easy way to do it is just to find the average of those. So if we find the average, so do 2 plus the second value to negative 4 divided by 2, an answer of negative 1. So our axis of symmetry is when x equals a negative 1. Part C, the coordinates of the vertex, just like we did in the first one. Because we have our axis of symmetry, we can put that x equals negative 1 into our original equation to work out the y coordinate of this point. And when we do that, we'll get an answer of negative 18. So our coordinates of the vertex are at when x equals negative 1 and y is negative 18. Then part D, we're just going to have a sketch of this function. All right, our x-intercepts are at negative 4, 0 and at 2, 0. Our y-intercept is at negative 16. And then our vertex is at negative 1 and negative 18. And then from there, we can just join the dots, make sure the vertex is at the lowest point, or the highest point, depending on which way around it is, and then draw your parabola. And that is the end of this video on the vertex of a quadratic.